Hi everyone. We're going to be talking about getters and setters again and access control. We're going to have a number of different lectures. We're going to expose you to the concept and then go a bit further and then go a bit further over and over again. So let's just jump right in. Hopefully this is going to be a short lecture, but at the same time I have a tendency of being long-winded. So you're probably wondering why I have a streaker in a cartoon for the beginning of this lecture, right? It's because exposing yourself, just openly exposing yourself or your data to others is not always the best thing in the world, let's just say, right? Sometimes you want some things that are private, that only you are seeing, because really no one else needs to see that. So in this case, when we're talking about object-oriented programming, some things are exposed to the world, some things are not. Put on a pair of pants, essentially. We're going to hide information so that only we know about it. We give specific access control to others if they need it. It's like a locked door or a key card, right? Can you get into the main office? I certainly hope not. I can because I'm one of the instructors here. So we have access control to the main office. Well, if we don't have COVID, right? We have access control. Not everyone can see everything. You cannot see how I'm grading things. You cannot see necessarily rather rubrics or what the instructions I give to the TAs, right? Sometimes you need to hide information. If everything's just exposed, bad, you have either too much information or people can exploit that in horrible ways. We also want to, just for your own, and people say, oh, it's not so bad. Even if it's not for malicious people, malicious actors or anything like that, it just makes your life easier. What we want is this car part talks to this car part through this particular method. What we don't want is some random interactions. So, like when we were talking about functions, if I roll down the window and the car horn honks, that's bad, right? You do not want weird interactions. So, the only way to guarantee this, because people have a limited amount, your head is only so big. I have a big head, but even my head's not that big. So even if you have, even if you're the brightest person in this room or whatever room you're in, it doesn't matter. There is an upper limit to what you can actually figure out. This kind of rigorous design structure allows you to separate your concerns so that this thing only draws. Fine. This thing only does this. The rectangle knows about the rectangle and knows how to deal with rectangles. And you have these interfaces that work with each other, but you don't have to worry about weird interaction effects. You don't have to worry about like this one class over there modifies my data. You have a methodical structure. Oh, I should actually put a slide here. I don't know if any of you have driven in other countries. I can only speak of France, but I know that India, from my friends from India that I've talked to, they've had differing opinions about roads and stuff like that. Just because where they were growing up, the lines on the road are more suggestions, at least for them, than they were absolute demands. Same thing with France. So we were driving around in France, and suddenly your lane would just give out, and you have to squeeze in front of you. And so people think the French are terrible drivers, but they're not. In fact, they're spectacularly good drivers. The road is terrible, right? The lane gives out, and you just gotta squeeze on in. If you don't have this kind of structure, it's a much harder to drive there because there's no structure. It's sort of like, you're going to figure out things. Having a really tight structure, really rigorous structure, means that you know exactly what to expect as you go. And it means that you can manage really, these sort of insanely complicated systems. At least it's less stressful for me. So if you have a rigorous approach, like what we're doing with object-oriented programming, it means you can scale this thing up to much, much more complicated things. A country road does not have to be perfectly immaculate, right? A country road does not have that many cars on it, and therefore you doesn't have to have the same rigor as this, 16 lane highway, which you need to have very strict rules and you need to make sure that people are, following those rules. And you worry about it from a very different scale. So, by default, all class members are accessible only from member functions. Okay, that's what you would hope at least. You don't want your member variables to be public. You want them only available to yourself. In fact, The default is what's called protected. So what we have is three different things. We'll look at them again soon. But we have public. If I have something that says public, let's do int foo. It means everybody and anybody has access to foo and can modify foo and can look at foo and can do whatever they want. Private means, and so we'll have this kind of thing. It's called foo2 because I'm not original, right? Foo2, nobody other than that object has access to it, can look at it. No one even knows it exists. It's like this ninja variable. Only the actual class knows about it. Public foo, this thing up here, the public one, that's very much like a global variable. It's open for anyone to modify to do whatever you want. And it's the same problem with global variables. If you took my 1400 class, you know I hate global variables because anyone, any place, anytime can change it. Public variables are like a global variable. Protected is a slightly different beast. Protected means that only friends and child classes, when we talk about inheritance, we'll look at child classes, can look at it. For right now, private and protected are going to look very, very similar. So if you're a student, should your parents be allowed access to your grades? Direct access without you knowing. I'm assuming most of you agree that they should not have direct access to your grades. You should be allowed to tell them if you want, but they should not be able to just look at your grades without you, right? Some parents have tried that in Carleton's history, by the way, in case you're wondering, or be able to read your emails. You should be in control of your own actions, and you give access to other people if they deserve it. Same with Facebook friends and the like. That's why none of you will ever be a Facebook friend of mine. Not because I don't want to be Facebook friends with you, but my sister keeps on posting incriminating images of me when I was on the swim team, a fat kid on the swim team way back in the day. Not happening. You're not seeing those. You can see a picture of me with an afro, but not that. So, I want to be able to control access, and the only way to do that is not to have everything public. I actually caught a couple of students cheating at Northeastern because their status and everything about themselves was publicly available, including that they were friends with each other, and they swore up and down that they didn't know each other at all. And sure enough, they're Facebook friends, and it was publicly available. Right? That's that. This is why you don't want everything being public. Um, right? So why do what about functions? Some functions I may want visible. Some functions, like things that are going to format your hard drive or involving that people don't really need to know about, you want those. You can make functions private. If the function is only useful for that particular class, make it private. No one else needs to see that. So you can do that. So here is some of the things you can do. So I have a class B, I have a class A, which has a function called foo. Here is me making the definition of the function foo right here. I have a function bar, by the way, as well. Let's put A. I make a new variable A called my A, very original name, and I want to call a.foo. I will get a compiler error because by default, the default up here in class A is protected. The default is protected. I will get a compiler error because I don't even see what foo is. One workaround, and it's a workaround I never use, but I want to just expose you guys to it. One workaround is to go up to A and say, B is a friend class. I will also need to include where B is. That's why we have those header files, by the way. But I need to say, by the way, there's going to be a class called B. Here's the definition of the class called B. But I will need a class called B at some point in time, and I'll link it up. And by the way, B is a friend. So you can do that sort of thing to give access. But now B has complete unfettered access to A. I can go to my A, call foo. I can go to my A.A and change the value for A. When it's a friend, it's not just a friend. They're more than just friends. Not even friends with benefits. Like it's a full blown. They have complete access to everything. You're married essentially to A. My wife's picking up my phone and looking at my phone and opening my laptop, looking at my laptop, and she has complete unfettered access to everything of mine. It's not a matter of like people like, oh, I wouldn't share my phone with my friends because they'll do something. No, no. This is similar to being married. They have access to everything, including your bank account, right? So what we don't want, so that's one way of working around it. Another way is to make public getter and setter methods, which is I think the better way. Public getter and setter methods, and then allowing B to get information. So if I make foo public, now I can call foo. Everyone can call foo. Why not public? Well, data hiding and abstraction is a concept that we're really trying to push. So I want this thing, this object, to do something as an abstraction. It takes in something, it spits out something. If I give you willy-nilly access to the data inside of it, it means it doesn't necessarily work the way I expect. If my engine has gasoline go in, something come out, but now I can just start randomly tinkering around and changing my engine, it does not mean that the engine will work the way I expected it to. If at any point in time anyone has access to the inner workings of that engine, the engine's not going to act like an engine anymore for very long. Non-public members can change through public functions, and that's sort of how we like to do things. Getter and setter methods. So if I want to set the name, I call a public function, and then the class or the object itself determines whether it's willing or able to change the value. It's really to just save you from yourself. This is effectively lazy once again, right? We don't want to be lazy generally. I want to be effectively lazy or efficiently lazy. I want to be efficiently lazy. I want to do it once, do it right, and not have to go back to it 3 months later. Efficiently lazy means when I make a change, I make these extra functions so that later on I don't get some weird side effect that I spend 20 hours figuring out. I spend 20 minutes or less writing the functions. If your data is publicly available, it's publicly exposed, be nervous. That is a just general rule. If you have a function that's publicly exposed, expect people to abuse it. I like this. This is actually the nicest random whiteboard thing that I've gotten, I think, or one of the nicest ones. This is from my class at Northeastern. They decided to put a little picture of the sort of last day of class. That's fine. It's right. It's a nice, cute little drawing. Now, do you remember the whiteboards in the labs? Maybe you don't remember some of the whiteboards in the labs. Almost invariably, every single weekend, you'd come in on a Monday, you'd open up the whiteboard, and there'd be either profanity or, can you guess? Yes, a picture of a penis on there, right? This is just what people like to do. Google, when they will put drawing, the ability to draw in Google Docs. I was at Google at the time. They said, hey, we have the ability to collaboratively draw pictures on a Google Doc. Here's a Google Doc that you can all play with during this presentation. Under 5 seconds, there was a penis on the doc, right? It just, and these are adults in industry. They're supposed to, no, first thing that they do, draw a penis. If you make something publicly exposed, you can expect people to do stupid crap with it, right? If I put a sign outside, I expect people to abuse it in some way, shape, or form. If I put a whiteboard outside, I'm expecting someone to write profanity. I'm expecting someone to write something, a dirty picture. I'm expecting something bad. Not everyone's going to do it, but somebody might. When you publicly expose a function, you got to expect people will give you garbage data. They will try and hack your system. They will try. That you have to be a lot more protective and a lot more defensive for a publicly exposed function than any other function. So you make a publicly available function, expect them to throw you garbage data. Have a scenario to handle garbage data. Because they can and they will, and somebody else is going to use your code and they're not going to know how you implemented it, and they're going to send you something that you didn't expect. You have to be a lot more defensive if anything is public. And if you have public access to your variable, they will modify your variable on you. Expect them to. So, our workaround is normally getters and setter functions. A getter function simply returns the data, the value of the data. And the whole point of the getter and setter function is I don't want to have anyone directly access or modify my data, but I want to be able to give them, read access to my data. That's what the getter method's for. Read access. Write access uses setter method, right? So I set foo. I pass in some value foo, or some variable in there, and I set it, and I error check while I do so. Getter methods give access, setter methods change the value, but I also make sure it's valid. And in case you don't think this comes up, this is something that came up over and over again. And this is that mouse cursor thing I talked about. We were making a video game, and I had all these if statements, if else statements everywhere in my code dealing with whether the mouse is in a valid position. And over again, I kept on replicating my code, checking to see if the value for the x and y position is safe. And the answer is have a set x method, a set y method. Those things check, and everything else just blindly sets the value. So my set method might take, I move my mouse, I say the x value moved over 20 positions. It was at position 10, it's now position -10, and your set method goes, okay, it's at 0. It's not at -10, it's at position 0. It allows you to figure it out once, do it right, and have one stop, like sort of one stop shopping for how you set values. You're not double checking, triple checking everywhere. You just let your set method handle making sure things are safe. So this is, or much like you do not have to, if you are at an office building, the front desk is where you block people from going, unauthorized people from going in. You don't have to lock every single door in an office building, you lock the front door. So that's what a setter method is. It's a publicly exposed thing that allows you to set variables, but they also double check and make sure that the values being set are safe. Okay, so we actually had a problem last time around. I'm going to skip over this slide a little bit because we had a problem last time with well, actually set name worked just fine, but for last time around, if I wanted set name, so get name is actually what was going to be the problem. Set name, what if you pass me null? Right? You say set the name null, right? You don't pass in any text. I want my system to intelligently handle that. Do I change the name? Do I keep the old name that I had? Do I set the name to an empty string? Right? These are the kinds of questions you want to ask yourself. In this particular case, if you send me null, I would expect to keep the old name or set it to an empty string. I would actually probably just keep the old name. If you give me an empty string, however, I'd change the name to the empty string. I want to figure out what the behavior is from a high level. I don't want to worry about the code itself. Just what happens? What happens if I call this function with this? Oh, it does that. Okay. What happens if I call it with this? Oh, it does this. What if the width is negative? What should my function do? You want to plan this out before you actually code anything. There's nothing to do with code. It's about thinking about what's going to happen if someone gives you garbage. And I want to do it in one place to save my ass. Okay. Here is, and what if I want the pixel map? I want the pixel map. If I pass a pointer to an image, so if I get the pixel map, this is actually something that you can actually do. And you have a function that says just get pixel map, and I pass back the actual data structure that is the image that I'm going to draw on the screen. A pixel map being all the various pixels, all the various lights, the colors that I have to make an image. If I have a method that just gives you back the actual data that you're storing, anyone can go in through there and just start stomping on that pixel data, and it'll actually change your image on you, the image that you're stored. So you want to make a copy of your image and pass that off, right? Google has this all as well. When I moved back to Canada, we had to change from our US accounts to a Canadian account, and every single one of their different services all require this, but it's done in one place. So when we finally figured out how to do it, we changed our country, and it's reflected across all of our Google services, from music to my Gmail to got 1,001 Google services. Uh, what you can't do is expect other programmers to do the right thing. If you give them access to it, they will screw it up, right? If I give someone access to, if I have to do set country code and someone else stomps on the data, I'm expecting someone's going to do something stupid. I go through one function and I make sure that the code is done correctly. And any confirmation, permission checking, all of that stuff is done in one place. Because the last thing you want is just letting other people, external people, modifying your data. Because they will do something wrong. If you've ever heard of code injection in JavaScript, that would be an example, right? It allows you to pass executable JavaScript code into your JavaScript program, and it will execute that random other code and do all sorts of weird, wonderful things to your code. If you give someone keys to your car, this is what they do, right? Not always, but this is Ferris Bueller's Day Off, right? And if I had a chance to drive that car, I'd be doing it too, right? You want to, this is you're handing off the keys. If you just give them publicly available memory variables, this is what they do. They will just drive off on it. You need some kind of control. Okay, so this is one way of looking at our code. Before, what we were talking about was we do sequential programming languages, what we end up doing is we do statement 1, statement 2. We just do an order of things. We might call some function which does step 1, step 2, step 3. That works for a large chunk of things. Object-oriented programming, the viewpoint is slightly different. The viewpoint when you're thinking about objects should be, I have this object and this object and this object. They talk to each other. They send information back and forth. I'm not worried about sequential step 1, step 2, step 3, step 4. What I have is the student then talks to the student grades. The student grades calculates an average, which then gets passed to a file, which opens up the file. But you don't worry about the series of steps that are going to be taken. What you worry about is, how does object A talk to object B? How do they both talk to object C? It's a different way of looking at the world, but I find it intuitive. So there's no one-stop shopping, there's no one way of doing this, but one way of looking at object-oriented design is to first figure out what objects you have. I will doodle up a bunch of boxes and squares and link up the boxes and squares before I code anything. I want to know where things are, how they are connected to other things. So I identify the objects or the entities. I identify the kind of classes I may end up having. I identify the properties. What does every single student need to have? What does every single grade need to have? Right? What kind of methods do I need? Which ones are public? Which ones are private? After all of that, I will spend, a day designing how everything is hooked up. And only after I've done this a bunch of times, made sure my plan is sound on paper, then I will actually implement some stuff. And what you're really trying to do is write glue code, such as your main function, etc. But I make all these methods, I make all these classes. The glue code is the main function. The main function just sends things off to these objects to do their work. The objects do their work, communicate with other objects to do their work. The main method is just now glue code. It says, hey, we're going to make a bunch of students do your thing. Read in this file, do your thing, spit out your answer, and then I'm done. But the objects themselves are doing all of the heavy lifting. The main method just starts the ball rolling. There is no magic formula though. It's an iterative approach. You're going to get it wrong. So you're going to make a class, you're going to say, that's a great class. You start writing it and you go, that was a stupid class. Everybody does. So maybe I start off with, I'm going to make a Mario game, so I'm going to need a sprite for the Mario character. I'm going to need a sprite for the enemies. I'm going to need sprites for the objects, the individual objects in the class. Maybe I need a separate sprite for interacting objects. And then I go, well, wait, these things have things in common. Everything is animating, so maybe I need something that is described for all a superclass, a thing that describes all the various things I'm drawing on the screen. And oh wait, maybe Mario has a separate set of instructions than the enemies, or maybe the enemies do different things in different situations, or maybe I want to be able to color swap the enemies, or maybe I want all of the, like, how you think it through will change over time, especially once you start coding. You go, oh, you know, I took a wrong turn here. In general, the things you normally think about are like physical entities, like a player, like a video game player, or an enemy on the screen, or a particular car, or something like that. It may be an action or a process, so maybe it's a filter, right? An image filter that changes things. It's like, think of it like a verb, right? It will change. It passes something through the filter changes the data and changes it to something else. Maybe it's the user interface. And then I might have data structure, like a data packet, right? Not a physical thing at all, but it's a data structure. And maybe it's a linked list, something like that. They're all, you can be considered an object that does something, right? The filter takes in an image and removes all the color blue. A player might be a sprite that you draw on the screen. The data structure might be a linked list where I store all the different players or the different characters that are on the screen at the time. Whatever the case is, they're all ways of thinking about breaking a big complicated problem into these objects that do stuff. And as if you can conceptualize that thing doing something and it makes sense to you, great candidate. So it depends on how you want to envision things. So how would you do this for a Pac-Man game? Right? This is actually it's very open-ended, very convoluted. We'll revisit Pac-Man in a second when we look at classes and inheritance. What does a Pac-Man game have? What kind of things do we need to worry about? How do things work with a Pac-Man game? So you're going to have some kind of timing. So the ghosts can move. If you remember Pac-Man, they have a bunch of ghosts that are trying to attack Pac-Man. Pac-Man is going around through a maze, picking up little pellets as it goes along, and there's power pellets, which suddenly when you pick up one of those, then you can eat the ghosts, and you get points for that. The ghosts, by the way, also do different things. They're different colors and have a different AI. The maps are going to be completely different randomized maps all the time. I have a bunch of pellets. The pellets are everywhere, but when the Pac-Man goes over the area, then the pellet's gone because it eats the pellet, right? How do I break down a really convoluted task like that? Try thinking about that for a second. Maybe doodle up something so you can have like your Pac-Man. It needs to know about the map. The map may have the power pellets or pellets. Lots of those. Or we could just put maybe a star on it. We'll see why in a second. And then I have enemies. Ghosts. How do you want? Do the ghosts know about Pac-Man? Do the ghosts know about this? Do they go through an intermediary, which is the map? Right? It's all open-ended. It's your job while you're doing this. You'll spend hours just figuring out how you want these things to interact with one another. Oh, I didn't know I had other text there. So the class game, we have a class game, we have a level that we're on, we have a score, right? We have a player class, we have an enemy class, we maybe have a score, a UI class. How do we draw things on the screen? How do we handle timing of events? Maybe I'll have a class for event timing, right? Anything is possible with this. And how you break down a big nasty problem into small little modular chunks that know how to deal with themselves, that's the challenge, and it's very open-ended. Okay, so I'm going to stop it right there, and next time around we're going to look at this, that, and the other thing. We're going to look at some other keywords, what's new in C++, and then we're going to revisit this whole public-private thing as well. Okay, and then we need to do a lot more examples just to make sure that everyone feels more comfortable. This takes time to finally sink in. We can talk about the theory, but it takes a bunch of iterative examples to finally get it. Okay? So with that, and that's why we do the practice in the labs and why we do the practice for the assignments. So just in case you're wondering why we do this, it starts coming into focus when you do the work. When you get your hands dirty, that's when things start coming into focus. Okay, on to this, that, and the other thing next class. Thanks, everyone.